The ability to update existing models and develop and produce appealing new models is a key part of the success of the Chrysler Group. And if past results are any indication, the two latest models should add to that success. Chrysler Pacifica is not an all-new model. However, the updates to it for the 2007 model year should make it an even stronger contender. Jeep Compass, on the other hand, is an all-new model that takes the Jeep brand in an exciting new direction. Welcome to MasterTech. This month, we'll be looking at features of the Pacifica and Compass that you need to know about. On Pacifica, for the most part, the program will focus on the 4-liter engine, hybrid bus system, and rear backup camera. And we'll have some other changes to tell you about along the way. On Compass, the focus will be on electronic brake controls and the 4-wheel drive system. Before we get into Pacifica's 4-liter engine, here's a quick rundown of the model lineup and powertrain. For 2007, Pacifica's model designations have remained the same: Base, Touring, and Limited. However, with the introduction of the 4-liter engine and the 62 TE transaxle, the powertrain lineup has changed. On front-wheel drive applications, base models receive the 3.8-liter engine and 41 TE transaxle. Touring models receive the 4-liter engine and 62 TE transaxle. On all-wheel drive applications, base, touring, and limited models receive the 4-liter engine and 62 TE transaxle. Along with the 62 TE transaxle, the 4-liter engine is one of the big changes to the Pacifica for 2007. This new V6 is the subject of the next part of the program. The 4-liter engine, which is being used in Pacifica and in future applications, is based on the 3.5-liter engine, which was used previously in Pacifica and is currently used in LX models. A longer stroke provides the additional displacement, and the engine is rated at 255 horsepower and 275 pound-feet of torque. Outside, new ribbing and bosses distinguish the 4-liter block from that of the existing 3.5-liter. As does a new oil filter and cooler location. Inside, you'll find that the top of the crankcase and portions of the block sidewalls have been machined to provide clearance for the 10-millimeter increase in stroke. The main bearing bore size has also increased from 64 to 69 millimeters. The connecting rod and piston assemblies have also changed. The 4-liter engine piston is dished and has a different skirt design. You can also distinguish them from 3.5-liter assemblies by the taper in the small end of the rod and the shorter, smaller diameter pin. In the 4-liter, rod and lower main bearings use a bimetal design, also different than the 3.5-liter engine. Another change is that the rod bearings are now select fit. The markings specifying the rod bearing sizes are located on the crankshaft below the main bearing markings. Rod journals for cylinders 1 through 6 are in sequence with a number 1 rod journal on the left. In addition to the differences in the block, another way to distinguish Pacifica's 4-liter engine is the redesigned oil pan. The pan features a revised sump and a thicker pan rail. Inside the pan, you'll find an integrated high-pressure oil feed and a return line for the relocated oil filter and cooler. Note that the new pan incorporates an engine-to-transaxle structural support and that it mounts directly to the transaxle. It is critical to follow the tightening sequence in the service information to ensure proper alignment. The 4-liter's oil pump is also different. However, it uses the same internal passages as the 3.5-liter engine on LX models. The oil pressure sending unit is mounted at the front on the pump housing. Along with a new oil pump and pan is a new oil pickup tube. At the upper end of the 4-liter, the valve train also has some features that distinguish it from the 3.5-liter engine used previously. The camshafts use a different profile with higher lift, and you can distinguish 4-liter camshafts from those used on 3.5-liter engines by the ID rings. To accommodate changes in the camshaft profiles, valve springs have also changed. The 4-liter intake spring is marked with a gray stripe and has a free height of 43.6 millimeters. The exhaust valve spring has a blue stripe and a free height of 47.9 millimeters. The 4-liter engine also uses a different valve stem seal. The valve covers on the 4-liter engine are thermoplastic instead of aluminum, and both the oil fill neck and cap install with a quarter turn. Note that the oil fill neck must be installed prior to the upper intake. Also note that since the 4-liter will be used in various applications, on Pacifica there's a cap instead of a PCV nipple at the rear of the left cover. Coils for the 4 liters coil-on plug ignition use 1 mounting screw instead of 2. To avoid cross-threading, be sure to seat the coil before installing the screw. The outer timing belt covers are also different than those used on the 3.5-liter. The 4-liter uses 2 covers. However, the upper one is smaller. The rear cover has an upper engine mount support cast into it. Speaking of engine mounts, the 2007 Pacifica uses a different design, and you'll need to follow the torque sequence in the service information when installing them. Like the Pacifica 3.5-liter engine, the 4-liter engine uses an outlet thermostat located on its redesigned lower intake. The water box is similar, and the bleed screw is in the same location. The engine inlet connector, located at the left front corner of the block, is serviced along with its seal as an assembly. One look and it's clear that the 4-liter upper intake manifold is a different shape than the manifold used previously on Pacifica's 3.5. But some of the changes are not so obvious. For example, on the 4-liter, the map sensor locks into place with a twist instead of being attached with screws. The 4-liter uses a short runner valve and a manifold tuning valve. However, the short runner valve is located at the front of the manifold, and the actuators are now monitored by the engine controller as OBD2 items. Also note that the support brackets are in a different location, and that there are ball studs to retain the engine cover. All Pacifica engines receive electronic throttle control for 2007, and the 4-liter uses the same throttle body as the one used on 3.5-liter LX engines. Another obvious difference between the 3.5-liter Pacifica engine and the 4-liter is the exhaust manifold. To reduce emissions, on the 4-liter, the catalytic converter is welded to the exhaust manifold. This is commonly referred to as a maniverter. There are 2 maniverter assemblies, one for the 45-state federal emission standard, and the other for the standard in California, New York, Massachusetts, Vermont, and Maine. If you need to service the all-wheel drive power transfer unit, note that it must be installed before the right side maniverter. Those are some of the main differences between the 3.5-liter engine used previously in the Pacifica and the 4-liter. Next, we're going to move under the Pacifica to see what's new there. In last month's MasterTech, we covered one of the changes to the 2007 Pacifica's drivetrain, the 62TE. Be sure to refer to that program for an in-depth look at this new transaxle. Another change to the drivetrain for 2007 involves the all-wheel drive system. For 2007, an electronically controlled coupling, also referred to as an ECC, replaces the viscous coupling and bidirectional overrunning clutch used previously. Also new for 2007 is the Bosch 8.0 electronic brake control system. In addition to anti-lock brakes, the new system includes brake assist and all-speed traction control. Brake assist is provided hydraulically by the HCU pump motor. Electronic stability program is now standard on all models. And later, we'll discuss Pacifica's hybrid bus system, which makes ESP possible. On Pacifica's exterior, you'll notice a new hood, fenders, grille, and front fascia. You'll also notice a new roof-mounted antenna that replaces the previous one located in the quarter glass. It's an active antenna that amplifies AM/FM signals, and it's also used for satellite radio on Pacifica's equipped with this feature. Next up, as promised, a look at Pacifica's new vehicle communication system and a feature that can make backing up a lot easier. Last year, in our Vehicle Communication Update program, we introduced you to a new type of vehicle communication system, which uses both the PCI bus and CAN bus. Designing a bus system in this way allows a vehicle to continue to use PCI for convenience features, while adding a high-speed bus for features such as ESP. For the 2007 model year, you can add Pacifica to the list of vehicles that use a hybrid bus system. The Pacifica bus system, however, is a little different than the ones we've covered in the past. The Pacifica system uses the CAN-C and CAN-C diagnostic, CAN-B, and PCI buses for vehicle communication. On the CAN-C bus are the Powertrain control module, the all-wheel drive module, and the anti-lock brake module. The steering angle sensor is also on CAN-C. The sensor cluster used for ESP operation provides information to the ABM over a dedicated bus line. On the CAN-B bus are the power liftgate module and the occupant restraint controller. The remainder of Pacifica's modules are on the PCI bus. On Pacifica, the body control module is the gateway, and it provides a link between CAN and PCI buses. A CAN-C diagnostic bus connects the data link connector to the BCM. The DLC also uses a separate connection to link to the PCI bus. The most important thing to keep in mind when dealing with this hybrid bus system is that you must use the StarScan or StarMobile to perform diagnostics. You may get a response using the DRB3, however, it will not provide accurate results. Our next Pacifica feature is one that customers should find really reassuring: the rear backup camera, available on Touring and Limited. Whenever the shift selector is in reverse and the key is on, the camera provides drivers with a wide-angle view. The camera is located in the liftgate on the license plate light bar. It receives a power feed from the backup lamps, so it's powered up only in reverse. A coaxial cable from the camera provides a video feed to the navigation display in the cluster, which has priority when the vehicle is in reverse. The camera itself is not on the bus. However, the cluster can record a no video signal diagnostic trouble code if it fails to receive a signal from the camera. In that case, be sure to check the camera's power and ground, as well as the coaxial cable. If the camera's image is blurry or obscured, be sure to check the camera lens for dirt or damage. And if the camera's aim is off, check the camera and light bar for proper assembly. There is no aiming procedure. Speaking of assembly, the light bar must be removed to service the camera. With available features such as the rear backup camera, standard features such as ESP, and the new engine and transaxle, Pacifica is going to win over customers in a big way. Next, we're going to look at the 2007 Jeep Compass, which is about to explore new territory for the Jeep brand. The 2007 Jeep Compass represents a new direction, one that will cause Jeep vehicles to appeal to an even wider group of customers. Let's begin with a brief rundown of the Compass model and powertrain lineup. For the NAFTA market, Compass is being offered in front-wheel drive and four-wheel drive, base and limited models. The 2.4-liter engine is standard on all models. A 5-speed manual transaxle is standard equipment, with a continuously variable transaxle optional. The export side uses the same base and limited model designations. However, both are four-wheel drive only. As with NAFTA, the 2.4-liter and 5-speed manual transaxle are standard with a CVT optional. Export models also offer an optional 2-liter turbo diesel with a 6-speed manual transaxle. Both Compass and Dodge Caliber are based on the same platform, and much of what you know about Caliber can be applied to Compass. We've covered many of the Caliber's features in previous MasterTech programs, and most of these can also be found on the Compass. In this program, we'll focus on Compass's four-wheel drive system and electronic brake controls, and you'll be able to apply much of this to Caliber. Before we get into specific details about these systems, it helps to have a general understanding of how Compass is different than other Jeep vehicles. Traditionally, Jeep vehicles have been configured for rear-wheel drive or four-wheel drive. Four-wheel drive models have used a transfer case and drive shafts to distribute torque. And while these vehicles increasingly use half shafts and independent front suspension, the rear has traditionally used a solid rear axle. Compass is a new kind of Jeep, one that's configured for front-wheel drive or four-wheel drive. On Compass, the transaxle sends power to the front wheels. A power transfer unit, drive shaft assembly, and rear driveline module send power to the rear wheels. And both the front and rear use half shafts and independent suspension. While the four-wheel drive system is different than other Jeep vehicles, like them, Compass uses electronic brake controls to enhance braking, traction, and stability. Next, we're going to take a closer look at both of these systems. On both front-wheel drive and four-wheel drive Compass models, the transaxle and front half shafts provide power to the front wheels. Four-wheel drive models have a power transfer unit attached to the transaxle. This ring and pinion gear set transfers power 90 degrees to a two-piece drive shaft. At the rear, the drive shaft connects to an electronically controlled coupling, or ECC, and a rear differential. Together, these two are referred to as the rear driveline module. The ECC uses a two-stage multi-disc clutch system to transfer torque. The all-wheel drive control module engages a smaller clutch pack electronically. This low-torque clutch then actuates a cam and ball mechanism to apply the main clutch. By varying the amount of current to the smaller clutch, the control module can vary the amount of torque transfer by the larger one. The all-wheel drive control module is located under the instrument panel in the passenger compartment, and it relies on such inputs as wheel speed sensors for its operation of the ECC. The rear differential is an open center design, and it sends the torque to the rear wheels by means of half shafts. The only manual system control is a four-wheel drive lever located in the center console. Cluster items connected with system operation include a lamp in the cluster that indicates four-wheel drive is operating, and one that warns of a trouble code or that the system may be overheating. Electronic brake control components not only provide anti-lock braking, they also work closely with the four-wheel drive system to enhance traction and vehicle stability. On left-hand drive models, the integrated control unit attaches to the right frame rail in the engine compartment. The ICU is made up of the anti-lock brake module, or ABM, and the hydraulic control unit, or HCU, which are serviceable separately once the ICU is removed. The ABM receives inputs from the steering angle sensor located in the steering column, and the yaw and lateral accelerometers located in the sensor cluster under the center console. It also receives inputs from the wheel speed sensors, and it uses the HCU to control brake application at the individual wheel brakes. An ESP switch allows drivers to alter ESP operation, and the cluster provides drivers with feedback by means of an anti-lock brake system warning lamp, an ESP and brake assist warning lamp, and an ESP and traction control indicator. The EVIC display in the cluster also has a warning that indicates when ESP is deactivated. With its integrated four-wheel drive system and electronic brake controls, the Compass can apply braking or transfer torque as necessary to enhance braking, traction, or vehicle stability. For optimum fuel economy during straight-ahead drive pavement conditions under steady speed or light acceleration, there's little torque transfer. Conditions which do result in torque transfer include in response to heavy use of the throttle. In such a case, the aim is to prevent wheel spin. The torque transfer is not in response to wheel slip and does not rely on wheel speed sensors for feedback. Loss of traction by the front wheels will also result in torque transfer. However, in this case, the system will rely on the wheel speed sensors to indicate that slip is occurring, as well as to manage the torque transfer. Compass's system will also transfer torque on tight turns to prevent binding in the driveline, and during cornering to improve handling when the vehicle is traveling between 25 and 65 miles per hour. With Compass, drivers can allow the system to automatically determine torque transfer, or they can modify the process by pulling up the four-wheel drive lever. Doing so results in a more aggressive torque transfer at low speeds. A four-wheel drive lamp in the cluster illuminates to indicate that four-wheel drive mode has been activated. For the most part, Compass's electronic brake controls operate in the same way as those on other current vehicles. During braking, the system provides anti-lock braking and brake assist as necessary, as well as electronic brake distribution. Whenever four-wheel drive engagement indicates the vehicle is on loose surfaces, such as gravel, anti-lock braking is modified to allow more wheel slip for improved stopping. During acceleration, electronic brake controls provide traction control through brake-limiting differential. This complements the torque transfer from four-wheel drive. And on turns, the electronic stability program corrects for oversteer and understeer conditions. Like other vehicles we've featured on MasterTech, Compass has three-mode ESP. Momentarily depressing the ESP off switch causes ESP and traction control to operate at a higher threshold. Holding the switch down for 5 seconds shuts ESP and traction control off at lower speeds. Over 30 miles per hour, the system returns to operation at a higher threshold. When ESP is off, the odometer will display a message indicating that it has been deactivated. In addition to its other functions, Compass's electronic brake controls also provide electronic roll mitigation, or ERM. ERM helps prevent wheel lift during vehicle maneuvers by applying the brakes on the outside wheels. That, briefly, is how Compass's four-wheel drive and electronic brake control systems operate. Next, we'll look at diagnostic and service features of these systems. In many cases, when a vehicle is brought in for service related to the four-wheel drive or electronic brake control systems, it will be because the driver was alerted by a lamp in the cluster. A blinking four-wheel drive warning lamp indicates that the system may be overheating. Keep in mind that this is a calculated value based on ambient temperature and clutch application time. A four-wheel drive warning lamp that stays on solid indicates that the all-wheel drive control module has recorded a diagnostic trouble code. Malfunctions in the electronic brake controls are indicated by the ESP BAS warning lamp or the ABS warning lamp that remains on after the bulb check. Use the Star Scan or Star Mobile to access the anti-lock brake or all-wheel drive control modules and retrieve any trouble codes. Then use the published procedures on TechConnect to troubleshoot codes. Be sure to follow the steps in the pre-diagnostic troubleshooting procedure for four-wheel drive diagnosis. Since ABS and four-wheel drive are closely related, checking for ABS codes is part of the procedure. You should also use the service information when it comes to repairing or replacing four-wheel drive and electronic brake control system components. Here's a brief rundown of some of the features of the four-wheel drive components. The power transfer unit uses 80W90 gear lube, and there are plugs for draining and filling the unit. The PTU can be removed from the vehicle without removing the transaxle. If you need to service the drive shaft on Compass, keep in mind that it is serviced as a unit. You cannot replace individual parts of the assembly. The same is true of the electronically controlled coupling. It is a sealed unit that is replaced as an assembly. It can be removed separately from the drivetrain. However, you'll need to lower the sway bar and rear driveline module to do so. The other part of the rear driveline module, the rear differential, uses 80W90 gear lube, and it has drain and fill plugs for service. In order to service the rear differential, you'll need to remove the rear driveline module and then separate the differential from the ECC. Before we leave service features, there's one more thing you need to know about, and it concerns the all-wheel drive control module. The module attaches to a slotted plate which mounts on studs under the instrument panel. To remove it, loosen the fasteners and rotate it out of position. For further training on servicing either the Pacifica or Compass, be sure to see the list of available courses in this month's Tech News. That's all we have time for this month. Be sure to join us next month when we'll be covering more new models from the Chrysler Group. Thanks for watching.